A scintillating morning to all my dear students. This is your science teacher Shaheen Miss, and I happily welcome you all to K-Tech High School and Junior College. Children, as you all know, we have started with our lesson number 1, Gravitation from Science 1, right? And today in this lecture, we shall be learning free fall and escape velocity. So let's begin. Let us first start with free fall. For this, children, let's try an activity. Take a small stone. Hold it in your hand. Now children, tell me which forces are acting on the stone? Now release the stone. What do you observe? What are the forces acting on the stone after you release it? The answers to these questions are: the force are acting on that small stone are the force exerted by the person holding it, the force exerted by the air, and the earth's gravitational force. Okay? After releasing the stone, it falls on the ground. The forces acting on the stone after releasing it are the force exerted by air and the earth's gravitational force. Okay? Children, we know that the force of gravity due to the earth acts on each and every object, right? Children, when we were holding the stone in our hand, the stone was experiencing this force, right? But it was balanced by a force, which was that we were applying on it in opposite direction. So, as a result, the stone remained at rest, right? Once we release the stone from our hand, the only force that acts on that stone is the gravitational force of the earth, isn't it? And then the stone falls down under the influence of gravitational force. Are you getting me, children? So, whenever an object moves under the influence of the force of gravity alone, it is said to be falling freely. Okay, so thus the released stone is in a free fall. So what is a free fall? It is a downward movement under the force of gravity only, or falling rapidly. Understood, children? So what exactly happens in a free fall? In a free fall, the initial velocity of an object is 0. Okay, and it goes on increasing due to acceleration due to gravity of the earth. Now everybody knows what is acceleration due to gravity, right? We have learnt this in our previous lectures. So during this free fall, the frictional force due to air opposes the motion of the object, and a buoyant force also acts on the object. So what is frictional force? It is the opposing force. Opposing means it does not allow. So frictional force is the opposing force that is created between two surfaces that try to move in the same direction or that try to move in opposite direction. So here during free fall, this frictional force due to air, okay, here there is air which opposes the motion of an object, and a buoyant force. Now what is buoyant force? It is the upward force exerted that causes the object to float. Okay, it also acts on the object. Understood what is actually happening in a free fall? So children, true free fall is only possible in vacuum. For a freely falling object, the velocity on reaching the earth and The time taken for it can be calculated by using Newton's equations of motion. Children, this Newton's equation of motion we have learnt in our 9th standard. Okay, so for free fall, the initial velocity, that is u, it is 0, and the acceleration, that is a, is g. So we can write the equation as v is equal to gt. S is equal to 1 upon 2 gt square, and v square is equal to 2gs. So these are the Newton's equations of motion for free fall. Okay, children? For calculating the motion of an object thrown upwards, acceleration is negative. Why? Because it is moving in the opposite direction, right? In a direction opposite to the velocity, and therefore it is taken to be minus g. The magnitude of g is the same, but the velocity of an object decreases. Why? Because of this negative acceleration. Now understood why we say it is negative? Because it is moving in the opposite direction. Okay, children? Now we can say that the moon and the artificial satellites are also moving under the influence of gravitational field of the earth. So we can say that they are in a free fall. Understood, children? Good. Let us learn the next topic, gravitational potential energy. Children, we have studied potential energy in our previous standards, right? So what is a potential energy? It is the energy stored in an object because of its position or state. It is called as potential energy. So this energy is relative and increases as we go to greater heights from the surface of the earth. So this potential energy, okay, it increases as we go at a higher or a greater heights from the surface of the earth. So let us assume that the potential energy of an object of mass m, as you can see on your screen, children, at a height of h from the ground is mgh. So this is the potential energy of an object at a height, okay, and on the ground the potential energy is 0. So when h is small, that is height, compared to the radius of the earth, that is r, so we can assume that g, that is gravity, to be constant, and we can use the formula mgh. So potential energy on the ground, on the surface of the earth, it is 0. But children, for large values of height, that is h, the value of g decreases with the increase in height. That is, if the height is more, okay, so the value of gravity will decrease as there is increase in height. Okay, so for an object at infinite distance from the earth, the value of g is 0, and earth's gravitational force will not act on that object. Are you getting me? What I am trying to say? If the object is at infinite distance from the earth, so what will happen? There will be no force of gravitation, right? So the value of g is 0, and earth's gravitational force will not act on that object. Now you understood? So it is more appropriate to assume that the value of potential energy to be 0 there. Thus, for smaller distances, that is less height, the potential energy is less than 0, that is it is negative. So when an object is at a height h from the surface of the earth, its potential energy is, what's the formula? Minus capital G capital M small m upon capital R plus small h. So here capital M is for mass and capital R is the radius of the earth. Understood, children? Now we will learn escape velocity. Children, we have seen that when a ball is thrown upwards, okay, in upward direction, so what happens? Its velocity decreases because of gravitation of the earth. The gravitation, right, the gravitational force, it pulls the ball towards itself, so its velocity will decrease, right? And at a certain point, okay, after reaching a certain height, the velocity becomes 0, and after that what will happen? The ball starts falling down, right? So its maximum height, it depends on its initial velocity, right? When we throw the ball upward, okay, so the height depends on what? Its initial velocity. How? Firstly, you throw that ball in upward direction, right? That is the initial velocity. It will depend on initial velocity. So we can say that according to Newton's third equation of motion. Now what is Newton's third equation of motion? V square is equal to u square plus 2as. Now what is V over here? V is the final velocity of the ball. So what will it be? Yes, correct. It will be 0. And A, it will be minus G. Why we are indicating minus G? Because the ball, it is thrown upward in the opposite direction. So we write acceleration in negative. We have just learned here in gravitational potential energy. Yes. Therefore we can write 0 is equal to u square plus 2 minus gs, and the maximum height of the ball, what it is? S. It is minus u square upon 2g. So higher the initial velocity, that is u, the larger is the height reached by the ball. Are you getting me? If the initial velocity is higher, so the height of that object will also be larger. Okay. The reason for this is that the higher initial velocity, the ball will oppose the gravity of the earth more, and larger will be the height to which it can reach. Children, we have seen that the value of G keeps decreasing as we go higher above the surface of the earth, right? So the force pulling the ball downward decreases as the ball goes up and up. Okay, so if we keep increasing the initial velocity of the ball, okay, if we keep increasing the initial velocity of the ball, so it will reach larger and larger, right? Larger and larger heights, and above a particular value of initial velocity of the ball is able to overcome the downward pull by the earth and can escape the earth forever and will not fall back on the earth. So what is happening? If we are increasing the initial velocity of the ball, so what will happen? It will reach at a larger and larger height, right? Then what will happen? If the ball is able to overcome the downward pull by the earth, which downward pull? The gravitational pull. And if it overcomes this downward pull, the ball can escape the earth. Yani it can move upward. Okay, it can escape the earth and it will not fall back on the earth. Okay, so this velocity is called as escape velocity. Understood, children? Now, if an object is going vertically upwards from the surface of the earth, having an initial velocity equal to the escape velocity, okay, then it escapes the gravitational force of the earth. Okay, it is escaping the gravitational force of the earth. It means that the object is to be free from the gravity of the earth and it has to reach the infinite distance from the earth. That is, the object will come to at rest at infinite distance and will stay there. Children, you must have seen the launch of a spacecraft, right? So the spacecraft which are sent to the moon or other planets have to have their initial velocity larger than the escape velocity, right? Why? So that they can overcome the Earth's gravitational attraction and can travel to these objects. So children, now you understood why these spacecraft travel to moon or other planets? Because they have the initial velocity is much larger than the escape velocity. So they overcome the gravitational attraction of the earth and therefore they can travel into the space. Understood, children? So with this, we have finished our lesson number 1, gravitation. I hope, children, everyone has understood all the concepts in this lesson. Children, after watching the video attentively, please do read the lesson. We shall see you in the next lecture with a new lesson. Till then, take care of yourself and your family. Thank you, children.